This is Module 4.1, Lifting Gases. Helium is a commonly used lifting gas and is used for upper air balloons worldwide. It's obtained primarily from natural gas wells and is readily available. The primary properties of helium are subdivided into two classes by whether the properties are hazards or not hazards. The non-hazardous properties of helium are that it's lighter than air, non-toxic, odorless, colorless, tasteless, and not flammable. Helium does have some hazards. In confined spaces, it can lead to suffocation, and compressed gas hazards are associated with high-pressure helium cylinders. Although helium is a very safe gas to use, there are operational difficulties in relying on helium for upper air observations. First, it's a finite resource, so it's getting scarcer and more expensive. But secondly, the cylinders are heavy and bulky, and this can make it difficult to transport to remote areas. Sable Island typically has enough helium cylinders on hand to provide for 30 days of use. Hydrogen is another gas that's lighter than air, so can be used for upper air measurements. Hydrogen provides about 8% more lift for the same volume, so is a more effective lifting gas. Hydrogen can come in cylinders like helium, and on Sable Island we've often had hydrogen cylinders to work with. But like helium, the cylinders are heavy and bulky, and this can make transport difficult. Hydrogen is a constituent of water, so it can be manufactured on site by electrolysis, and this is the primary source of hydrogen on Sable Island. Hydrogen can also be manufactured on site by chemical methods. Sable Island has had different types of chemical generators in the past, but they are now considered obsolete. Hydrogen has many properties in common with helium. The non-hazardous properties are hydrogen is lighter than air, not toxic, odorless, colorless, and tasteless. Hydrogen also has hazardous properties. Like helium, hydrogen is an asphyxiator, and in confined spaces can lead to suffocation. Hydrogen has compressed gas hazards associated with the high-pressure storage tanks and the hydrogen cylinders. And hydrogen is flammable when mixed with air. Hydrogen has all the same hazards as helium, but also is flammable, and that risk of flammability is the big difference between hydrogen and helium. To help in categorizing how flammable a gas is, we describe it in terms of its explosive limits. If we start with pure air and add a very small amount of hydrogen, there isn't enough hydrogen to burn. But as we increase the amount of hydrogen, we find that when we get to a concentration of 4%, it becomes flammable. This concentration is referred to as the lower explosive limit, or LEL. If we add more and more hydrogen into the air, we continue to have a flammable mixture until we eventually get to the point where there's so much hydrogen and so little air that there isn't enough oxygen to support combustion. This point is reached when there's a concentration of 74% hydrogen and is called the upper explosive limit, or UEL. The flammable range for hydrogen in air is therefore between these two limits, 4% to 74%. Below 4%, there isn't enough hydrogen in the air to burn. Above 74%, there isn't enough oxygen in the air to enable the hydrogen to burn. The table shows the range of explosive limits for a variety of common gases and vapors. Hydrogen's range of 4% to 74% is wider than most flammable gases or vapors, and explains why hydrogen is treated with so much care. But a big advantage of hydrogen is that it's lighter than air. Hydrogen will float upwards, and if we provide a vent, it will escape into the free air where its concentration is well below the lower explosive limit. Gasoline and propane are commonly used fuels, but they're heavier than air and will pool in low spots, adding a significant hazard. If pure hydrogen gas ignites, the burning will occur at the edges of the gas, where the mixture of hydrogen and air can support combustion. If hydrogen gas is mixed with air, the burning will occur throughout the gas at very high speed, and instead of a fire, you'll have an explosion. The most explosive concentration is around 48% hydrogen in air. A hydrogen-air mixture is very easy to ignite. Hydrogen, propane gas, or gasoline vapor can all be ignited by static electricity, but hydrogen needs less than 1/10 the amount of energy needed to ignite propane or gasoline. So while the wide range of flammability in air is one important part of the hazardous nature of hydrogen, the hazard is greatly increased by the very small amount of energy needed to ignite it. You may have experienced a small electric shock generated from static electricity after walking on a carpet. A static spark with sufficient energy to ignite a hydrogen-air mixture is so small that it's not felt and it's not visible. Static sparks are most likely to occur in drier air. Sable Island has a moist marine climate, so doesn't usually have much risk of static electricity. In some operations in drier climates, the technicians spray a water mist in the room to increase the humidity and reduce the risk of static buildup while inflating balloons. Some operations also prohibit rubber-soled shoes or nylon or polyester clothing, as they promote static buildup. By ensuring all conductive surfaces are grounded, we can further reduce the risk of static electricity. Hydrogen flowing through a hose can also generate static electricity if it's flowing fast enough and if there's dust or other particles present. We can minimize this risk by restricting gas flows to speeds slow enough to avoid generating static. Hydrogen has a nearly colorless flame when pure, similar to other fuels like alcohol and natural gas. Any color in the flame is due to impurities like moisture and particles in the air. Without bright colors, the flame can be hard to see in daylight. But the lack of a bright flame is also an advantage in that it doesn't ignite other materials with radiant heat. The safety measures that will prevent hydrogen from igniting are pretty simple. First, ensure the gas is pure and not contaminated with air. For hydrogen in cylinders, it's already pure from the factory, but for hydrogen manufactured on site, regular testing is needed to ensure the gas is pure and uncontaminated. Prevent hydrogen leaks. Regular maintenance checks are needed to ensure lines, fittings, valves, and other hardware are working properly and not allowing hydrogen to leak out. In addition to regular maintenance, we also have an electronic gas detector that will sound an alarm if hydrogen is detected where it shouldn't be. Monitor the balloon inflation closely and check the balloon for pinhole leaks. Ensure proper ventilation. Since hydrogen is lighter than air, vents located at the ceiling will provide a path for any hydrogen to escape the area. Control ignition sources. This means no smoking, no battery-operated equipment, and no power tools near the balloon shed. We also need to control static electricity by proper grounding of all surfaces and controlling gas flow rates. This concludes the module on lifting gases.